Hello everyone and welcome back. I hope you had a chance to work on the homework from the previous lesson. If you couldn't solve it, don't worry. Today we're going to solve it together and then we'll continue with something new. Remember what we said in the last lesson. A good programmer doesn't start by writing code. A good programmer starts by understanding the problem. Once you understand the problem, everything else becomes much easier. So let's look at the homework. The problem was very simple. We wanted to create a program that asks the user to enter their name and then prints that name on the screen. Before we think about code, let's analyze the problem. What exactly are we trying to do? We're asking the user to enter a name and then we're displaying that same name. So what is our input? The input is the user's name. And what is our output? The output is the same name displayed on the screen. Now that we understand the problem, writing the algorithm is very easy. We simply start the program, read the user's name, print the same name, and then end the program. That's it. Notice that we still haven't written a single line of code. We're only thinking about the solution. And this is exactly how programmers work. Now here's an important question. What if our program becomes much bigger? What if instead of 4 steps, we have 30 steps or maybe 50? Reading a long list of text becomes difficult, right? So how can we make the solution easier to understand? This is where flowcharts come in. A flowchart is simply a visual representation of an algorithm. Instead of writing the solution as text, we draw it using shapes connected by arrows. This helps us understand the program much faster. That's why many software companies use flowcharts before writing any code. Throughout this course, we'll use a free program called Diagrams.net Desktop. It's simple, free, and perfect for drawing flowcharts. Before we write code, we'll first think, then draw our solution, and finally write the code. Now let's learn the 4 basic flowchart symbols that we'll use most of the time. The first one is the start and end symbol. Every program has a beginning and an ending. So every flowchart starts with start and finishes with end. The second symbol is input and output. Whenever we read information from the user or print something on the screen, we use this shape. The third symbol is the processes. We use it whenever the program performs an action or a calculation. And finally, we have the decision symbol. We'll use this whenever the program needs to make a choice, like asking a yes or no question. Don't worry too much about it today. We'll use it a lot in the next lesson. Now let's draw the flowchart for our homework. We start the program, then we read the user's name, next we print the name, and finally we end the program. See, it's exactly the same algorithm we wrote before. The only difference is that now it's much easier to read because it's visual. Now let's solve another simple problem together. This time, let's create a program that asks the user to enter their age and then prints it on the screen. Again, before thinking about code, let's analyze the problem. This input is the user's age. The output is the same age displayed on the screen. Now let's write the algorithm. Start, then read age, then print age, and end. And finally, let's draw the flowchart. As you can see, nothing really changed. We're following exactly the same thinking processes. First, we understand the problem. Then we write the algorithm. After that, we draw the flowchart. And only after that do we think about writing code. Now, before we finish today's lesson, there is one important rule that I want you to remember throughout this entire course. Divide and conquer. Whenever you face a big problem, don't try to solve everything at once. Break it into smaller problems. Solve the first one, then the second one, then the third, and before you know it, the big problem is solved. This is one of the biggest secrets behind how professional programmers think. They don't solve a huge problem in one step. They solve many small problems one at a time. And from today on, every single problem we solve in this course will follow exactly the same processes. We'll understand the problem, we'll analyze it, we'll write the algorithm, we'll draw the flowchart using diagrams.net desktop, and only then, if we need to, we'll translate the solution into code using any programming language we want. Notice something very important. An algorithm doesn't belong to C++. It doesn't belong to Python. It doesn't belong to Java. An algorithm is simply the solution. A programming language is just a tool we use to translate the solution into code. And that's why if we become good at problem solving, learning new programming languages will be much easier. And that's exactly the goal of this course. Now it's your turn. I'd like you to solve today's homework. Create an algorithm and flowchart for a program that asks the user to enter their favorite color and then prints it on the screen. Don't write any code, just analyze the problem. Identify the input and the output, write the algorithm, and finally draw the flowchart. Write your solution in the comments and I'll be happy to read it. In the next lesson, we'll solve our first problem that includes a decision. And you'll learn how programmers make choice based on different conditions. We'll start solving real programming problems, beginning with very simple examples, and then we'll gradually increase the difficulty step by step. By the end of this series, I don't just want you to know how to write code. I want you to know how to think like a programmer, like a professional programmer. Thank you so much for watching. Don't forget to like the video, subscribe to the channel, and I'll see you in the next lesson. Anytime, code smart, not hard.